For question 7 from Chapter 4 homework, we're asked to complete the balanced molecular chemical equation for the reaction below, and if no reaction occurs, to write NR after the reaction. So we've got two things going on. We've got lead 2 nitrate reacting with potassium iodide. So we have to find the possible products of that reaction and find the balanced equation for this reaction. I added in the solubility table so we could see what possible products would be. In general, one way to kind of figure out possible products would be that the first and the last are going to come together, and then the two middle components are going to come together as well. Maybe I'll do that in blue so it shows up a little bit easier. So two possible products are lead iodide, and the other possible product is potassium nitrate. So we can see here that I have two nitrates, and we know that nitrate is -1 each. That makes the lead 2+. Iodine is a halogen. That means iodine's always going to be 1-, and so that means for this to balance out lead 2 iodide, we're going to need 2 iodides to balance out the 1 lead. So this is not a balanced equation. I'm just writing out what are two possible products to form. Now, for there to be a reaction to occur, something needs to precipitate. So one of these needs to be insoluble in solution. So if we go down here, all group 1 metals are always soluble. So that means potassium nitrate would be soluble. We can go down here even further to see that nitrate is also always soluble. So potassium nitrate, always soluble. However, if we go down here far enough, we go to the halides, chloride, bromide, or iodide. Those are soluble unless I have silver, lead, or mercury present in solution. We have lead in solution, which means we are going to precipitate lead 2 iodide. So that means now I can write a balanced molecular equation for this reaction. So I've got lead 2 nitrate, which is aqueous in solution. That's going to react with 2 potassium iodides, which are also aqueous in solution. I need 2 potassium iodides because I need 2 iodine to balance out lead 2+. That reacts, and that's going to yield lead 2 iodide, which is a solid, plus, now for this to balance out, because I have 2 potassiums here and 2 nitrates here, I'm going to form 2 potassium nitrates aqueous. And so there's our balanced molecular equation for this reaction. For question 8, from Chapter 4, write the balanced molecular chemical equation for the reaction of aqueous solution of ammonium sulfate. So ammonium sulfate would be NH4, that's +1. Sulfate is SO4 2-, so that means I'm going to need to have 2 ammoniums to balance out the sulfate. That's aqueous, and that reacts with iron 2 chloride. Which they tell us is aqueous as well. So, for this, we want to figure out 2 possible products for this reaction. We're going to do the same thing. We're basically going to combine the first and the last, and then I'm going to combine the middle 2 components to see what are possible products. We know the first 2 are soluble in solution. So my 2 possible products, and again, this is not balanced, I'm just drawing what are possible products for this reaction. So ammonium is NH4 +1, so ammonium chloride would simply just be NH4Cl, and that's balanced as is with respect to charge. And the second product of this reaction would be iron sulfate. Iron is 2+, sulfate is also 2+. Now we want to figure out what, if anything, would precipitate from this reaction. So if we look, And we see down here, ammonium is always soluble. So this would be aqueous in solution. And if we look down here for the sulfate, sulfate is always soluble unless it is with silver, calcium, strontium, barium, or lead. We have iron, so that means this will be soluble as well. Now this one's kind of tricky because a reaction will only occur if something is precipitating. So if we're going from aqueous and aqueous to aqueous and aqueous, there's no driving force for this reaction because nothing is precipitating and leaving solution. Therefore, the answer for question 8 is simply just NR. No reaction will occur because nothing will precipitate from solution. For question 9, we're asked to write the balanced complete ionic equation for the reaction when potassium hydroxide reacts with copper 2 nitrate. Both of those are aqueous in solution. So again, 2 possible products. We're going to switch the first and the last. So one possible product is potassium nitrate, and the other possible product is copper hydroxide. Nitrate is always soluble. Group 1 metals always soluble. So potassium nitrate, always soluble. Nitrate is a -1 charge each. So if I have 2 of those, copper needs to be 2 plus. Hydroxide is -1. So I need 2 of those to balance out the 2 plus on copper. Now to figure out if something's gonna precipitate, I'm gonna come over here to hydroxide. Hydroxide is insoluble unless it is with group 1 metal, calcium, barium, strontium, or ammonia. Copper is not a group 1 metal, which means we're going to precipitate hydroxide from solution. So now let's balance this equation, right? I'm going to have 2 nitrates, so that means I need to have 2 potassiums to balance out my potassium nitrate. Now my hydroxide is balanced, my potassium is balanced, my nitrate is balanced, so we've got a balanced equation. Now we need to write the complete ionic equation. The complete ionic equation basically is anything that's aqueous in solution is written as ions in solution. So the complete ionic equation would be 2 potassiums, aqueous, 2 hydroxides, aqueous, plus copper 2 plus, aqueous, 2 nitrates, aqueous, yield 2 potassiums, aqueous, 2 nitrates, aqueous, and thankfully, right, we only ionize aqueous compounds, so copper 2 hydroxide solid. We do not need to write that as an ion. But that would be the complete ionic equation for this reaction. For question 10, we're asked to write the balanced net ionic equation. So the difference here with net ionic equation, basically we're going to remove spectator ions. When copper 2 sulfate, so copper is 2 plus, sulfate is 2 minus, so copper 2 sulfate would simply be CuSO4, and ammonium hydroxide. Ammonium is NH4, hydroxide are mixed in aqueous solution. So sulfate is always soluble with copper, so that would be soluble. Ammonium's always soluble. Those two are mixed together. My 2 possible products would be copper hydroxide and ammonium sulfate. So we know all ammonium containing compounds are always soluble, so that makes this aqueous. And we know hydroxide is only soluble with group 1 or some group 2 metals. So copper hydroxide is insoluble. That's going to be a solid. All right, let's see if we can balance this equation. I've got 2 ammonias, so I need 2 ammonium hydroxides, and the equation's balanced because now I've got 2 hydroxides, check, 1 copper, 1 sulfate, 2 ammoniums. So there's our complete molecular equation. Our complete ionic equation, we would ionize everything that's aqueous in solution, so copper 2 plus, sulfate 2 minus, plus 2 ammoniums, NH4 plus, aqueous, 2 hydroxides, aqueous, yields, thankfully our copper hydroxide is a solid, and the second component, right, my 2 ammoniums, NH4 plus, aqueous, and my sulfate, SO4 2 minus, aqueous. That is our complete ionic equation. Now to find our net ionic equation, we want to remove our spectator ions. Spectator ions go through the reaction unchanged. They are the same on both sides. So my ammonium cancels out, my sulfate cancels out, and that leaves me with a net ionic equation of copper 2 plus 2 hydroxides will yield solid copper 2 hydroxide. That is our net ionic equation for this reaction.